solving a system with 3 variables does take the skills that we have with solving a system of 2 variables like we've done before and just builds upon that. So I want to take this moment to kind of work through this with you and see how this is going to play out. You'll notice that we have 3 equations and 3 variables. So this follows what we know about systems. You have to have as many equations as you have variables. And so just kind of looking at our system here, let's start to kind of notice some processes that we know. We know that if we're trying to solve any given system, we could use the process of elimination if we were to create an opposite on a certain letter. And so notice that just by looking at this and not manipulating, we've got opposites on these z's. And so what I'm going to do is I am going to take 15x minus 10y plus z equal to negative 38. And I'm going to work with the third equation. And I'm not sure where to start this, but I know that in the elimination, that if I have opposites on a variable, that's a really good starting place. Because now, following rules of elimination, I'm going to add those two together. So my z's would cancel, and I'm left with 9x minus 6y equal to negative 21. So at least I've gotten something down into something I'm familiar with of x's and y's. Now let's look at it. So this took into account this first equation and this third equation. So let's do something with that second equation. 12x minus 11y plus 2z equal to negative 40. Relate it to the first or third. Maybe we could create some x and y situation. So this z is kind of causing me some trouble here. So what I'm going to do is I'm going to use the fact of z being 2 and the negative 1. And let's see if we can use the elimination to cancel out that z. And so now I'm taking the combination of this second equation with the third. And I'm going to try again to cancel out the z. So then maybe I can take like these two results and put them together with x's and y's. Because we know how to work with that. So I look at it and say, okay, looking at this situation here with the positive 2 and negative z, I know that I would need to multiply through in the bottom by 2, and that would create an opposite. So that would give me negative 12x plus 8y. I'm just distributing this. Minus 2z equal to 34. And I'm going to combine that with that second equation. So when I add these two together, negative 40 and 34 gives me negative 6. This cancels, which was our hope, gives me a negative 3y. But our x is actually canceled. So this actually worked out better than we thought it would, because now I can just finish solving this out for y's, and that gives me a positive 2. And so y equal to 2, I've already got one of my solutions. My goal is to get all 3. Well, since we already did this work in the beginning, let's take y equal to 2 and plug it in over here. So 9x minus 6 times 2 equals negative 21. And so now I can solve this out. So I'm going to add 12 to both sides. Gives me 9x equal to, let's see, negative 21. And our positive 12 is going to be negative 9. And then divide by sides by 9. So x equals negative 1. So I'm already to my x value. Now, in order to find my z value, all I need to do is just plug into one of the original situations. And so I'm going to plug it into the top one. Doesn't matter which one I plug it into. So I'm going to take 15x minus 10y plus z equal to negative 38. And I'm going to plug in the values I know. So I know that my x is negative 1. I know my y is 2. I'm just taking it from this piece and this piece. Plus z equal to negative 38. So it gives me negative 15 minus 20 plus z equal to negative 38. Combine these two together. It gives me negative 35 plus z equal to negative 38. And then add 35 over. So it gives me z equal to negative 3. And so you can see what we were able to implement in these 3 variables is the fact of, we can see in this first step, we use 2 equations in elimination to get it to x and y. In this step, we used two equations in elimination, and it actually gave us a y value, so we went back over here and found the x value. And then we took both the x and y value, plugged them into a situation to solve for z. And again, we can go in through the process and check all these. We can plug in every x, y value into all three equations. They'll give us true statements, and then we can see how that works out. So we're able to take our skill of solving a system and now implement it in a harder situation. Now, you can see this is very lengthy, and so we want to explore this idea of three variables, and then we'll build upon it.